This is Unit 4 Practice Exam Version B, Solutions. Question 1, we have a system. This is a linear equation, but this is a nonlinear. So the two options to solve a system of nonlinear equations, remember, is either using the substitution or the elimination method. Elimination method works great, but only if your variables are like terms. None of these variables are like terms. So we're going to have to use the substitution method. So I'm going to take this top equation, add the x over. This is going to become y equals x minus 3. So then I can take this x minus 3 and substitute it in for that y. So then the bottom equation becomes x squared plus x minus 3 squared equals 9. And then expand x minus 3 squared is x squared minus 6x plus 9. And then combine some like terms there. And then factor. And the solutions for x are x equals 0 and 3. So when x equals 0, we need to solve for y. So we use this equation here. So when x equals 0, y then equals, instead of x minus 3, I'm going to replace that x with 0. So this is 0 minus 3, which means y equals negative 3. So one of the solutions is when x equals 0, y equals negative 3. Now for the other value of x, 3, do the same thing. Now when x is equal to 3, we're going to say y is equal to 3 subtract 3, which means that y equals 0. So that solution is when x equals 3, y equals 0. For question 2, we need to solve a system of equations with 3 variables, 3 equations. I'm going to use the elimination method. I noticed right off the bat that for the y variable here and here, we have opposite coefficients for equation 1 and equation 2. So I'm going to combine equation 1 and equation 2. And using elimination method, eliminate the variable y. I have an equation that has still 2 variables. So we can't solve that one because it has one too many variables. So I need to go back and repeat this with 2 other equations. I need to eliminate the same variable as in step 1. So here I eliminated y. So I'm going to take equations 2 and 3 here. And in order to eliminate y, I need to have a negative 4 as a coefficient here. So I'm going to multiply that equation by negative 4. This is going to give me negative 8 plus 2, negative 6. This is going to give me negative 4y and positive 4y, so those are going to cancel. This is going to give me negative 16z minus 2z is negative 18z. And then I'm going to get negative 8 plus 8, which is 0. So we have another equation, has the same 2 variables as this equation. So now we take these two and make a system of equations. And continue to solve for one of the variables. So I'm going to solve for x. Means I need to eliminate z. So if I want to get z eliminated, I need this to be a positive 18 so it can cancel with the negative 18. So I need to multiply top equation by 2. Now I get 6x and negative 6x, so that cancels. I get 18z minus 18z, so that cancels. and then 0 plus 0. So we still have 0 is equal to 0, which is an indication of infinitely many solutions. So it states here that if we have infinitely many solutions, we still need to state the solution to the system of equation in terms of the parameter z. So z is just equal to itself. Now notice in either this equation or this equation, we have x and z. We know that z is just going to equal itself, so we can solve for x in terms of z. So go back here and make the statement that 3x plus 9z is equal to 0. If I subtract 9z, I get 3x equals negative 9z, and then divide by 3, I get x is equal to negative 3z. So now I know that z is equal to itself, x is equal to negative 3z. Now we just need to solve for y in terms of z. So I'm going to take this middle equation, since y has a coefficient of positive 1. I'm just going to take this middle equation here, and then substitute negative 3z in for x. So 2 times x becomes 2 times negative 3z, which is negative 6z. And then if we combine the like terms here, negative 6 and positive 4, that's negative 2. Adding that to the other side would become positive 2z. So y is equal to 2z plus 2. Now we have the value of all three variables. X was equal to negative 3z. Y is equal to 2z plus 2. And then z is equal to itself. Okay, so question 3, we're solving using an augmented matrix. And then we perform row operations to get this into row echelon form, which is 1, 0, 0. That's our first task. 1, 0, 0. This should be a 1. That should be a 0. So we're pretty much there. This needs to be a 0. This one already is. So just need to multiply by negative 1 here and add that to row 3. So negative 1 times row 1, add to row 3. We're going to make a new row 3. So that makes 1 times negative 1 is negative 1 plus 1 is 0. Negative 2 times negative 1 is 2. 2 plus 1 is 3. 1 times negative 1 is negative 1 plus 3 is 2. And 1 times negative 1 is negative 1 plus 8 is 7. So we have 1, 0, 0. If this wasn't a 1, if it was any other number, we would need to make that a 1 by multiplying this number by the reciprocal fraction. But since it's already 1, now we can focus on making this equal to 0. So if I multiply the middle row by negative 3, that's going to put a negative 3 here, which when added to 3 is going to be 0. So that's my row operation. Negative 3 times row 2, add that to row 3. It's going to become a new row 3. So 0 times negative 3 plus 0 is still 0. 1 times negative 3 is negative 3 plus 3 is 0. 2 times negative 3 is negative 6 plus 2 is negative 4. And 5 times negative 3 is negative 15 plus 7 is negative 8. And technically it's not in row echelon form, but we can still solve now. It's far enough along where we know that negative 4z equals negative 8, which means that z is equal to 2. So then we use that middle row to represent the equation y plus 2z, which remember z now is 2. 2 times 2 is 4. If you subtract 4 from 5, we get y equals 1. And then that top row represents the equation x minus 2 times y, which in this case y is 1, plus z, which is 2. So negative 2 plus 2 is 0, so x equals 1. So the solution is x equals 1, y equals 1, and z equals 2. Okay, part A here. When you're multiplying two matrices, first thing to check is if the multiplication is possible. So A times B means you have a 3 by 3 multiplied by a 2 by 3, so that's not possible. For part B, we have a 2 by 3 and a 3 by 3, so that one is. Let's go ahead and do that. So this entry is combining that row with that column. So we have 2 plus 2, it's 4, plus 0, so 4. This entry comes from combining that row with that column, so multiplying negative 2 times 2, that's negative 4. Negative 2 times 1 is negative 2, so negative 4, negative, that's negative 6. And another negative 2 makes negative 8. This entry is a combination of that row with column 2. So we have 1 times 1, that's 1, times, or plus negative 2. So 1 plus negative 2 is negative 1, plus 0. We have negative 1. This entry is this bottom row with the middle column. So we have a negative 2 and a positive 2, which makes 0. And then 1 times 1 is 1. 0 plus 1 is 1. And then finally, this entry is a combination of row 1 with column 3. So 5 plus 8 is 13, plus 0 is 13. And here we have negative 10 plus negative 8, that's negative 18, plus 0 is negative 18. For part C, we have 2 times B minus 3 times C. And the only way you can add matrices if both matrices are the exact same dimension. So this is 2 by 3 and 2 by 3. So then the scalar multiplication just means every entry gets multiplied by, in this case, 2. And on the other matrix, everything's multiplied by 3. And then we subtract terms that are in the same spot. So like 2 subtract 18, it's negative 16. 4 minus 6 is negative 2. 0 minus negative 6, positive 6. Negative 4 minus 12. Negative 16, negative 4 minus 0 is negative 4. And 9 minus, or 2 rather, 2 minus negative 9 is 11. Solve the system using an inverse matrix means means we need to create a matrix equation. And solve for this matrix xy, because that's going to tell us the value of x and the value of y. Now this matrix is being multiplied by this matrix, so in order to get this matrix by itself, we have to cancel this matrix. The only way that's done is if we can multiply it with its inverse. So if we consider this to be matrix A, then the inverse of A is 1 over that product, which is 6, minus this product, which is negative 1. And then remember, these two terms change places. And these two terms change sign, so that becomes a positive 1, that becomes a negative 1. So there's the inverse. So if I was to take this matrix and multiply it here, then they would essentially cancel each other out, leaving xy all by itself. But since this is an equation, if you multiply by the inverse here, you have to multiply by the inverse, by this same inverse right here. So it's going to be this times that. And I'm going to leave the 1/7 out. So I'm going to multiply the two matrices together first and then multiply the 1/7 at the very end. So this entry combines the top row with column 1, so that's positive 2 added to 12, which is 14. And then here we have positive 1 added to negative 36, so that's negative 35. So then I take the 1/7 and multiply it to that matrix. So then the xy matrix is equal to that result to negative 5, which means the solutions are x equals 2 and y equals negative 5. For part B, we do a similar process. We have to set up a matrix equation. Now, where part B is quite a bit more challenging is in order to get this matrix XYZ isolated, we'd have to figure out the inverse of this and then multiply. Now, the inverse of a 3 by 3 is very challenging to find, so that's why it's been given to us right here. This is the inverse of that. So all that we need to do, if we were to multiply this to that, cancels out, which means we also need to multiply this matrix to that matrix. So that's what we need to show. Is this matrix multiplied by the matrix 8, 6, 14. So this entry is combining that row to that column. So we're going to have negative 24, positive 72, and it's going to be 42. So you add negative 24 to 72 to 42. That makes 90. This entry is that row to that column, so 13 times 8, that's 104, and then negative 60 and negative 14, so we have 104 plus negative 60 plus negative 14, and that's 30. And this entry is row 3 with that column, so 8 and 8, that's 64, minus 12, minus 28, and that's 24. So now we take that 1/18 and multiply it into this matrix. "90 divides by 18 evenly, but 30 does not, so that's going to be 5/3, and neither does 24. That's going to be 4/3. So then our solution is x equals 5, y equals 5/3, and z equals 4/3. For question 6, remember Cramer's rule involves determinants. When you have two variables and two equations, you need three determinants. Determinant D is a determinant from the coefficients. So this determinant of a 2 by 2, remember, is this product. Always start with that one. So 3 times 12 is 36 minus this other product, which is 35. The next determinant, remember, follow the subscript. X means that the x column, the coefficients of the x column are going to be replaced with those two values. And find the determinant. So negative 7 times 12 is negative 84. And then 5 times 7 is 35. That's negative 119. And finally, this last determinant, if you follow the subscript, y means that these coefficients in the y column are going to be replaced with negative 7 and 5. The x column is going to be the same as it was originally. So this determinant is going to be 3 times 5, which is 15, minus negative 7 times 5, which is negative 35. That equals 50. So then according to Cramer's rule, the value of x is dividing those two determinants, d sub x divided by d, and then the value of y is dividing these two determinants, d sub y divided by d. So the solution is negative 119, comma 50. For part B, we're going to do Cramer's rule again. Simplified version though, because we only need to solve for the z variable and not all three of them. So for Cramer's rule, z is equal to determinant d sub z divided by the determinant d. So the determinant d is just going to be the coefficients. Now to find the determinant of a 3 by 3, I'm going to use the method, one of the methods shown in class, which was copying those first two columns over here to the right side of this matrix, and then multiplying these diagonals. So always start from the top left down to the bottom right. So 4 times 1 times 8 is 32. Negative 2 times 0 times 2 is 0. And 3 times negative 6 times 7 is negative 126. Now we multiplied all three of these diagonals going from the bottom left to the top right. So 2 times 1 times 3 is 6, 7 times 0 times 4 is 0, and 8 times negative 6 times negative 2 is 96. Now, these numbers add, remember, and these numbers subtract. So 32 plus 0 plus negative 126, then we subtract 6, subtract 0, and subtract 96. So 32 minus 126, that's negative 94, minus 6 minus 96. That's negative 196. So repeat this process for d sub z. So the subscript means the z column is going to have the values here after the equal sign, 6, negative 2, and 24. Then we're going to copy those first two columns again. So from the top left to the bottom right, 4 times 1 times 24 is 96. Here we have negative 2 times negative 2 times 2, which is 8. And here we have 6 times negative 6 times 7, which is negative 252. Now from the bottom left to the top right diagonals, 2 times 1 times 6 is 12. 7 times negative 2 times 4 is negative 56. And then 24 times negative 6 times negative 2 is 288. So those numbers I have written in red, those add. And then the numbers I have written in blue subtract. So then 96 plus 8 minus 252. These numbers, those first three at least, combine to negative 148 minus 12 plus 56 minus 288. Combining all of those makes negative 392. And then we have the determinant d sub z was negative 392. Determinant d was negative 196. So dividing those two, we get z is equal to 2. For partial fractions, we learned a couple of different variations depending on the denominator. In this case, we have repeated linear terms there. So we're still going to have two partial fractions, but since they're repeated and they're repeated twice, first time you write the factor, the second time you write the factor, in this case to the second power. Now when we multiply the whole equation here, we're going to multiply this by the lowest common denominator, which is x plus 3 squared. When that multiplies over here, the denominators x plus 3 squared cancel out, so you're just left with 7x plus 14. When this multiplies here, x plus 3 cancels with one of these x plus 3's, so then a multiplies the other x plus 3. Now when this x plus 3 squared multiplies to this partial fraction, the whole x plus 3 squared cancels out, leaving just b. So we have one equation to solve for two unknowns. So at this point, the process I described in class was choosing a convenient value. So if I wanted to solve for b, I'd have to cancel a, meaning that I could make this term turn into 0 by letting x equal negative 3. So if we let x equal negative 3, then here we get negative 21 plus 14, which is negative 7. Here, negative 3 plus 3 is 0, so a disappears, leaving just b. So b equals negative 7. Now, in order to solve for a, we have to have b turn into a value, not a variable, and we already know the value of b, so for the second step, I'm going to let b equal -7, but we also have to have x turn into something. Now, I don't want to let x equal -3 again, because that's going to make a disappear, and I want to solve for a, so I'm just going to let x equal some random value, like x equals 0. So I'm plugging in x equals 0 and b equals -7. So if x equals 0, I get 0 plus 14, which is 14. Here, 0 plus 3 is 3. 3 times a is 3a, and then plus b turns into plus -7. If you add 7 to 14, you get 21. So then divide by 3, and a equals 7. So the partial fractions are +7 over x plus 3, and then a -7 over x plus 3 squared.
For question 8, when you're solving an application problem, again, what you need to do first is identify the question. Here it's how many gallons of each type. Each type in this question, there's 3: regular, performance, and premium. So if we're going to define our variables, we need to have 3 variables. So then x is the number of gallons for regular, for plus, and for premium. Now the next task is to find the same number of equations as number of variables. So if you have 3 variables, we need to come up with 3 equations. Now the first piece of information here is that on a particular day there were 6,500 gallons of all of the gas sold. So 6,500 gallons would be a combination of the number of gallons X of regular gas, the number of gallons Y plus gas, and then the number of gallons Z of premium gas. So if you add those 3 together, you'll get 6,500 gallons of gas. Now the next piece of information is that the total amount sold that day is $20,050. So to figure out the equation for that, it's $3 per gallon times the number of gallons of regular gas. Add that to $3.20 times the number of gallons of plus gas, performance plus, and then $3.30 times the number of gallons of premium gas. So if you add those 3, this is the amount made on regular, this is the amount made on premium plus, this is the amount made on premium, then that amount is $20,050. Now, this next statement here, 3 times as many gallons of regular as premium. Regular was defined as X. Premium was defined as Z. So this statement connects X to Z. So what it's saying is if we have X and Z, right now it is not true that they're equal to each other. The number of gallons of regular is not equal to the number of gallons as premium. What it's saying is 3 times as many gallons of regular was sold. So this number X is already 3 times as big. So in order to make them equal to each other, we need to multiply Z by 3. Now they're equal to each other. Since this was already 3 times as big, if I multiply Z by 3, now they have the same number, they have the same value. So X is equal to 3Z is the equation that comes from this statement. So if I want to get it equal to 0 and get the variables on the same side, I'm going to have X minus 3Z is equal to 0. That's where this third equation came from. So now, once we have the 3 equations set up, we need to solve them. This bottom equation has Y as the missing variable. So what I'm going to do is solve the top 2 equations and eliminate Y. So if I take this top equation and multiply it by -3.2, this is this top equation multiplied by -3.2. Then when I add the middle equation, now the Y variables are going to eliminate. So this is -0.2x. This gives me 0.1z. So this is an equation in terms of x and z. This was already an equation in terms of x and z. So I'm going to combine this equation and this equation. That's where That's where this system came from. It was a combination of this equation and this equation. So now if I want to eliminate x, for example, then first of all, I'm going to multiply this bottom equation by 10 so I don't have decimals. So that's where this equation came from. I multiplied the bottom equation by 10 to get rid of the decimal. And then if I wanted to eliminate x, I would multiply this top equation by 2. So that's where this equation came from. So now x eliminates 6, or z in negative 6d makes negative 5z. So then z is 1500. And according to this statement, 3 times as many gallons of regular is premium. So if the number of premium was 1500, then 3 times that is 4500. So that's regular gas. And then there's only 6,500 gallons to go around that day. So you add these together to get 6,000. If you subtract that from 6,500, here we go. If you subtract 6,000 from 6,500, that's where the 500 came from. So 500 gallons of Performance Plus, 4,500 gallons of regular, and 1,500 gallons of premium.